Hey everyone, it's your Sally Coach, and today we'll be decoding an affine cipher when we are given our A and B values. So with that stated, let's get on with the cipher. Alright, so getting started with the cipher, the first thing we're going to be seeing is our A and B values. So it tells us that we have our first A value as 23. So we have A equaling to 23, and we also have B equaling to 23. Now, what are we supposed to do with these values, right? What does this do? Why are we trying to find this out? We're going to put this into a formula. Y is equal to the inverse of A times x minus b mod 26. Now, this has some weird words, right? We're not exactly sure what some of these are. We don't know what some of these symbols or variables mean, right? Like, we're not sure what inverse or maybe y is talking about. So let me dumb it down for you. So we're trying to decode our ciphertext to our plain text. So that's going to be our p. That's going to be our y. So our plain text is going to be equal to the inverse of a, and we're going to take our a value, which is 23, and we're going to go to our resource sheet. When we go to our resource sheet, we're going to find one of these tables, and we're also going to find this table, which I'll get to in a little bit. But this table, we can first look at the top set of letters and see that there's 23 right here. And we can see that the inverse of 23 is going to be 17, so we're going to write the inverse of a to 17. Then we're going to multiply this by x minus b, and x is going to be our ciphertext. And whenever I say ciphertext, I mean like if we look at our second letter right here, H, right? We're going to take H, go to this table, and see that H goes to 7. So we would put 7 in the X position, or the ciphertext position. After that, we're going to subtract by our B value, which is 23. We're not going to manipulate it in any way. And then we have mod 26. Now, modulus, that's pretty much saying that you're going to have to add or subtract 26 to get to a certain range of values. So we're going to be adding and subtracting 26 until we get our plain text to be greater than or equal to 0 or less than or equal to 25. Now, this is the certain range that I chose because we're going to have values ranging from A to Z. And we want only the real letters. We can't have anything less than 0, or we can't have anything greater than 25. This is why we're going to be adding or subtracting 26, so we get somewhere in this region. So now, let's try doing it with the first letter. We can look at F and see that F goes to 5. So we're going to have 17 times F minus 23, and then we're going to put this into 17 times negative 18, and we're going to use our calculator. So we're going to have 5 minus 23, which is equal to negative 18, times 17, and now we're going to add or subtract 26. Now, since it's in the negatives, we're going to add. And if it was higher than 26, then we would subtract. So I'm going to add 26, and you can see that it's taking a little bit of a while, right? It would take a long time. So instead of adding by 26, we would take some multiples of it and instead add by that. So now we can just add by 52 instead, or even higher, 104. And we can go farther and farther based on how big our numbers are. So now we can see that we get the value 6. And 6 follows this range of values that we have. So we're going to look and we're going to see that 6 decodes to G. So our first letter in our affine cipher is going to be G. And we're going to fill it out in every single area that we have in F. Now, for every single letter that we try out, like H, X, L, right? We're not going to write this out every single time because that's going to take too long, right? We're going to put it straight into the calculator. So I'm going to restart my calculator. We're going to find H to 7. So 7 minus 23 times 17. And now I'm just going to add by 104. Add 104, add 52, add 26, and now I get 14. 14 goes to O, so I'm going to put H as O. Now, another trick I want to tell you is whenever you're trying to find letters pretty fast, I think the best way to figure out a letter the fastest is the value of A. Since A is 0, we can say that our X value is going to be set equal to our b value. If we do this, we can get our x minus b equal to 0, and we know that any number times 0 is only going to be equal to 0. So if we get that value, so in our situation, our value would be 23. So we would go and look and see that x is equal to 23. And now we know that x is going to decode to 8. So we have x to 8. And now I'm going to fill this in all the other spots that I have remaining. Another trick I want to give you is that you can pretty much guess some of the letters when solving an affine cipher, because we can see that not many letters can fit in that space right here. So we can simply just guess and say that this works for good. And now we can continue going on. I forgot an H right here. Yep. And now we can continue going on. So we would have n, which is 13. So 13 minus 23 is negative 10 times 17 plus 104 plus 104. And then we went too far, so we would just subtract by 26. And we get the 12 value. 12 goes to m. And then you need to find all other areas where it has n. And now we can also do it based on frequency. We may not want to do a certain letter soon, because we may see that V is a letter that we may want to do quickly, because that could give us a lot of extra letters. Or we may go for L, like if we can find out the value of this L right here, we can probably tell what this word may be. Or we could probably figure out what this word may be, since L is pretty important in this word situation. Same thing goes for Y over here, so we may go for Y first. We have to do this pretty quickly so we don't waste too much time. So I'd say that the first letter that you think pops up a lot in your words is the one that you should go for first. Like we can see Y, Y, Y. There's a whole bunch, right? So I'm going to go look for Y, which is 24. 24 minus 23, we know that's 1. So we have 17. So 17, that's going to be R. And now we have Y to R. Y to R. And now we can also tell the word right here. AR, not too many letters would make sense here other than E, also based on the frequency and how much E is appearing. So I would put L to E right there, and I believe that's all the spots. So now I'm going to go back to K. K is 10, so 10 minus 23 times 17 plus 104 plus 104 plus 26. That's 13. 13 is n. Now we can say that this is probably manners. We also have an S right here. And we can tell that this is going to be of, because we ruled out the possibility of on. So of, and then good, and then we're not sure exactly what this could be, so we're going to take Q. So it's going to be 16 minus 23 times 17 plus 104 plus 26, and that's going to be 11, which is L. So now we have to do E and S now. E is going to be 4. So 4 minus 23 times 17 plus 104 plus 208 plus 26, 15. 15 is P. So I'm going to take it and I put it right here. And we know that this is going to be part. So we get the quote, good manners are part of good morals. Now, I just want to thank you for watching the entire video and staying through each and every step of the Affine decoding process. And if you have any questions or if you want me to release any extra videos on certain ciphers, then please comment down below so I can get those videos out first. At the moment, I'm going alphabetically from A to Z, so next I will be going over certain Baconian ciphers, maybe columnar after that, and so on. So again, if you have any type of request or recommendation of what cipher I should do next, please comment down below so I can get it out. And I just want to thank you one more time for listening to the entire video, and I hope you have an amazing rest of your day.